today we are going to see linear block code problem. This is Benira. So linear block code, a block of code of length n has k message bit and then n minus k parity bit. And this block code is said to be linear block code. If two codes are added together, the resultant is nothing but another code word. It is said to be the linear block code. The matrix description for n comma k linear block codes. So to find your code vector, the formula is x is equal to m into g, where x is a code vector, m is a message vector, and g is a generator matrix. So here x is nothing but of size 1 cross n, and matrix vector should be k message bit, so 1 cross k, and generator matrix will be k cross n. So next is your generator matrix. Generator matrix is given by I is to P, right? So generator matrix is going to be your K cross N. So in this one, identity matrix is IK, and then this P, that is the submatrix, is nothing but K cross Q. So check matrix is given by C is equal to M into P, where C is equal to check vector, M is message vector, and P is a subvector. So here this is given by 1 cross Q, and then your message vector is 1 cross K, and then this is nothing but your K cross Q. So next is going to be your parity check matrix. Parity check matrix is given by H is equal to P transpose into IQ. So the transpose of this submatrix and then your IQ, and your check matrix is going to be Q cross N. Error detection is given by the formula D minimum Hamming distance, minimum Hamming distance greater than or equal to S plus 1, where S is the error detection. Error correction is given by D minimum greater than or equal to 2t plus 1, where T is your error correction. So you can solve a problem. For a systematic 6,3 linear block code, the generator matrix is given as this way. So find all the code vector. Number 2, minimum Hamming weight. Number 3, draw the encoder circuit for the code vector. 4, error detecting and correcting capabilities. And then parity check matrix. So we'll solve one by one. First, they ask you to find the code vector. The formula to find the code vector is x is equal to your m into p. There's m into g here. So we can go for the check bits and then we can find the code vector. So before that, given it's a n comma k, that is 6 comma 3. So n is 6 and then k is equal to 3. So your parity bit q is n minus k, which is going to be your 3. So the generator matrix of Ik is to your Pk cross Q. So here in this generator matrix Ik, your K is going to be your 3. So 3 cross 3 matrix is going to be your identity matrix. So diagonally it's going to be 1. And this is going to be your P matrix. This is going to be your submatrix P. So from this one I can take this P as 1 0 1 0 1 1 1 1 0. So I'll be getting my check vector, where check vector is equal to C is equal to M cross M into P, where C is equal to your 1 cross Q, M is equal to 1 cross K, and then P is going to be your K cross Q. So 1 cross Q is going to be your 3. So I can write this as C1, C2, C3. Message is also 3, M1, M2, M3. This is going to be your P. So do the multiplication. Take your this row, multiply with this column. So M1, M2. Here all the addition will be of modulo 2 addition. So C1 is equal to M1, M2 plus M2, and C2 is equal to, here it is M2 plus M3, and C3 is equal to M1 plus M2. So with this formula I can get the table, code vector table here. So if it is going to be, this is your message vector, check bits, code vector. So here I have 3 message bits, M1, M2, M3. So the possible combinations 2 power 3, 8. So 0, 0, 2, 1, 1, 1. I will be calculating the check vector C1, C2, C3 with the help of this bit. So here M1, M2, M3. So going to be 0, 0, 0. So irrespective of your thing, your check bit is going to be 0, 0, 0. Now it's going to be for 0, 0, 1. So your C1 is M1, M3. So 0 plus 1 is going to be 1. It's a modulo 2 addition. And then C2 is M2 M3. So 0 plus 1 is 1. And C3 is M1 M2. 0 plus 0 is going to be 0. Then for this one, so C1 is M1 M3. So 0 0. C2 is M2 M3. 1 plus 0 is 1. And then C3 is M1 M2. 0 plus 1 is 1. And then here this one, for this one, your C1 is M1 M3. So 0 plus 1 is 1. Then M2 M3. So 1 plus 1 is 0. C3 is M1 M2. So 0 plus 1 is 1. C1 is M1 M3. So 1 plus 0 is 1. C2 is 0 plus 0 0. C3 is 1 plus 0. And then for C1 for 101, so it's going to be 1 plus 1, it's going to be 0. Then 0 plus 1 is 1. And then 1 plus 0 is 1. Again for the next one is M1 plus M3. So M1 plus M3 is, so 1 plus 3 is going to be your 1. And then M2 plus M3 is going to be 1. And then M1 M2 is going to be 0. Then here it is going to be M1 M3 is going to be 0. Then it's always going to be the 0. So the combination of these things will give you the code vector, message and then your check bits. So message and then the check bits will give you the code vector here. So this is going to be the code vector. So next is they ask you to find the error correcting capabilities here. For that one, you need to know the Hamming weight. So we'll calculate the Hamming weight W of x. So the first one, the value is going to be 0. So Hamming weight is, if the comparing with the two code vectors, the number of bits it gets varied is going to be the weight. For example, for this one, you just compare this one. Same, 1. The it's get varied. So 1, 2, 3. So 3 bits it gets varied. So Hamming weight is 3. And then for this one, 1, 2, 3, 4. So your Hamming weight is 4. How many bits it get varied with the previous code vector? So it's going to be 1, 2, 3. And for this one, 1, 2, 3. And for this one, 1, 2, 3, 4. And for this one, 1, 2, 3, 4. And for this one, 1, 2, 3. So here, this is going to be the Hamming weight, and minimum of this one, you have to leave this 0, right, by calculating a minimum. Apart from that, which is going to be minimum, 3 is going to be the minimum. So the minimum is going to be, D min is going to be 3. So from this one, we can calculate the next part of it, 1, right. So draw the encoder circle for the code vector. So we have the equations as C1 is equal to M1 modulo addition M2. We have the M1 modulo addition M1 modulo addition M3. And then C2 is going to be your M1 M2 modulo addition M3. And then C3 is going to be your M1 modulo addition M2. So we have your message vector M1, M2, M3. Check bit is C1, C2, C3. So here we'll be getting your C1. How will you get your C1? M1, M3. So you're going to get your M1 and then M3. Perform your modulo 2 addition. You'll get your C1. Similarly, C2 is M2, M3. So it's going to be M2, M3 modulo addition will get you the C2. Then for your C3, M1, M2. So it's going to be M1, M2 modulo addition will get you C3. So the combination of this M3 and then your C3 will give you the code vector. This is the encoder diagram. Then we'll see the error deducting and correcting capabilities. D min is greater than or equal to S plus 1. So D min value is 3. So 3 greater than or equal to S plus 1. If you take this plus 1 this side, it becomes 3 minus 1, 2. So S is equal to 2, the maximum value. This is error detection. You can detect two errors. Error correcting capabilities. This is d mean is equal to greater than or equal to 2t plus 1. So here 3 greater than or equal to 2t plus 1. If you take this plus 1 this side, so 3 minus 1 is going to be 2. So 2 divided by 2 is 1. So t is equal to 1. This is your error correction. So parity check matrix is given by H is equal to P transpose into identity matrix. So you know the P. So P transpose is changing the rows into columns. So you're changing the rows into columns. So 101, 011, 110. So this rows columns is converted into rows. It's going to be the same value here. So and then so this is going to be the P transpose. And this is your identity matrix. So this is going to be your parity check matrix. Thank you guys. Have a nice day. Subscribe my channel for automatic updates.